So you found the skeleton. How would you tell it was dinosaurs? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there YouTube, the Dapper Dinosaur here. You may remember that a while back I did a video that was about Dr. Jonathan Sarfati's abysmal lack of knowledge of bird and more general dinosaur anatomy. And I mean, this guy would fail like Intro to Comparative Anatomy. He's just a moron. This is the same guy who defied anyone to find a feathered animal with an open acetabulum. You know, something which is met in every single one of the 10,000 or so known bird species. Anyway, it was brought to my attention that some channel had made a response to me. I watched the rambling video and noticed that it was just a bunch of stuff cribbed from creation.com articles. So rather than subject you to a video that couldn't even get past 200 views a month and a half after release, I'll just respond to the articles in question. The first one is, Did Dinosaurs Evolve into Birds? By Jonathan Sarfati and Robert Carter, published April 16th, 2015.
Most evolutionists now believe that birds evolved from dinosaurs. However, there are well-informed evolutionary dissenters who are experts on birds, such as Alan Fiducia, his late colleague Larry Martin, Thiegarten Langham Soliar, John Rubin, and Storrs Olsen. As with many issues, we should differentiate between observations and interpretations of these, and between the direct teachings of Scripture and models to elucidate these teachings. While Scripture is non-negotiable, models should be held loosely.
So all of these folk have a couple things in common. One, they are members of the so-called bandits. BAND is an acronym for Birds Are Not Dinosaurs. And the bandits are all scientists who have decided that no matter what the evidence, they will simply insist that birds are not dinosaurs. They have been basically laughed out of the room when it comes to science. The second thing that they have in common is that they all think that what birds did evolve from was actually related to dinosaurs anyway, but basal to true Dinosauria. So they in no way help the creationist case. Even these hacks are not so deluded as to think that their alleged problems for bird-dinosaur evolution would be problems for evolution. Every one of them to the man except the obvious conclusion that birds descended from non-bird archosaurs.
So first, it's important to discuss what the Bible says, as well as what it doesn't say, either directly or by logical deduction. Second, it's important to show what unique creatures birds are, with many design features for flight. Third, some of the main candidates as evolutionary transitional forms are discussed. Finally, there are huge problems with the evolutionary story, even if we accept their dating methods.
Creation Ministries International, or CMI, might find it important to discuss what the scripture says, but I don't. I'm cutting their discussion of Genesis right out. I don't care about it. We'll cut back in when the science resumes. The only interesting thing that they say is that the scripture doesn't preclude feathered dinosaurs, but damn if they're not going to try their hardest to pretend that such things don't exist. You know, for reasons.
Special features of birds. Since heavier-than-air machines must overcome gravity, they need some balancing upward force, which comes as a direct result of the special shape of their wings. Birds, and now airplanes, have wings shaped as aerofoils, so that as they move forward, air is deflected downward. This is due to the fact that the wing is angled slightly upward during flight, the angle of attack. And because the air follows the curve on the upper surface, the Coanda effect, which eventually points down. This downward airflow produces an upward force, lift, because of the third law of motion, which was discovered by the esteemed creationist Sir Isaac Newton. Every action has an equal and opposite reaction. You can feel this strong downdraft of air under a helicopter's rotor, which is essentially a rotating wing. Airplanes need a motor to move forward, while in birds, this effect is produced by flapping. Birds' primary flight feathers are angled in such a way that they also force air backward, so the bird is also propelled forward, again in compliance with Newton's third law. Birds accomplish this with an intricate pulley system. The supracoracoideus muscle pulls on its tendon, which winds around a pulley comprising the coracoid and clavicle bones. The tendon is anchored to the humerus or upper arm/wing bone. Birds can still fly with a tendon cut, but takeoff is badly hindered. it is highly questionable that natural selection would drive the many coordinated changes needed to form this pulley system. Indeed, there is no evidence of transitional half-pulley systems in the fossil record. And would such a half-pulley be any use at all? In other words, how could natural selection select for the early stages of this system when those half-finished stages are of no use to the animal and quite likely detrimental?
Well, the interesting bit here is the fact that the closest relatives of birds among the dinosaurs had this same pulley-type system. So even if we don't have half-pulleys, we do have dinosaurs that are already bird-like using it. Further, the tendons of a bird wing are simply extensions of the tendons that occur in other tetrapods. For example, try flexing your arm like a bodybuilder. That bulge of muscle on top is the bicep. It is the main muscle responsible for letting you bend your elbow. It attaches to the radius in your lower arm via the distal bicep tendon. In birds, the propatagium tendon attaches from a bundle of muscle fibers split off from the bicep, and instead of attaching to the proximal end of the radius, it instead attaches to the distal end. But nothing about that is some crazy puzzle. Having a variation in the exact placement of muscle fibers is the kind of thing that happens all the time with mutations. And any mutation that pushes some of the muscle fibers to attach more distally will then allow for this tendon to provide additional low-energy retraction. As it happens, exactly this kind of arm movement was used by Maniraptoran dinosaurs to capture prey. Like everything in evolution, the tendons in a bird's wing are modifications of the basal anatomy of their ancestors.
Alan Fiducia, a world authority on birds at the University of North Carolina at Chapel Hill, and an evolutionist himself, says, quote, "Feathers are a near-perfect adaptation for flight," end quote, because they are lightweight, strong, aerodynamically shaped, and have an intricate structure of barbs and hooks. This structure makes them waterproof, and a quick preen with the bill will cause flattened feathers to snap into fully aerodynamic shape again.
While Fiducia has become what is technically referred to as a hack fraud, he is right here. Modern feathers are quite well adapted to facilitating flight, and since they've been evolving for that purpose for around 150 million years, that's not too surprising. Nor would Dr. Fiducia disagree with me here, since he himself thinks that feathers evolved from archosaur scales. In this, he is essentially in line with the mainstream of biology that knows birds are dinosaurs.
Some evolutionists claim that feathers evolved from scales, but scales are folds in skin. Feathers, on the other hand, are complex structures with barbs, barbules, and hooks. Feathers also originate in a totally different way, from follicles inside the skin in a manner akin to hair. Finally, feather proteins, phykeratins, are biochemically different from skin and scale proteins, alpha-keratins, as well. It is nonsensical to think that any animal would accidentally stumble upon the special function, shape, biochemistry, and anatomical developmental pathway of feathers by chance, especially when the intermediate stages have little to no known survival advantage.
Well, scales aren't really folds of skin, except in certain squamates like snakes. But hey, why bother with nuance when you can just lie for Jesus, right? So what is a scale then? Well, a scale is essentially a thick, hard bit of skin. It develops from bumps on the skin in embryo called a placode. Interestingly enough, mammal hair, bird feathers, and reptile scales all develop from placodes. After the initial thickening, scales just get thicker. Feathers form a circular ridge, and hairs fold inward, creating a little dimple that will become the hair follicle. From there, each one grows, and if the placode is just left to develop, at that point you'll get the simplest form of each integument. A bumpy lizard scale, a simple mammal hair, or a simple protofeather filament. We have every stage of feather, from simple filaments, to split filaments, to symmetrically branching filaments, to plumaceous feathers, to pennaceous feathers. All preserved in dinosaurs. We have every single transition that evolution would predict if feathers evolved from archosaur scales. Further, the feather protein listed here, i.e. theta-keratins, which CMI contrasts with alpha-keratins of the skin and scales, are in fact a subset of beta-keratins. Beta-keratins are known from reptile scales, crocodilian scutes, and interestingly, bird feathers. CMI is simply incorrect when it says that scales are made up of alpha-keratin and leaving it at that. And in fact, the implication that feathers lack alpha-keratin is incorrect according to the source they used, namely Molecular Organization of Avian Epidermal Structures by Alan H. Brush and Gene A. Wild, published in, get this, 1982. Yep, at the time that Carter and Sarfati wrote this article, they were citing a biochem paper that was already 32 years out of date. But either way, In their own source, the claim is made that simpler keratins in feathers are likely alpha keratin, while the phi keratins are responsible for the complex branching of feathers. Of course, this is exactly what we would expect if feathers had evolved from reptile scales made of beta keratin, that the beta keratin would adapt to be more complex and branching, which is why it now falls into the phi keratins, again, a subset of beta keratins. In fact, the paper they cited supports homology for all phi keratins, meaning that they all likely shared a single common ancestor protein that itself was a modified beta keratin.
Bird lungs are very different from reptile lungs. A reptile lung is like a bellows, that is, air is breathed in and blood takes up the oxygen and releases carbon dioxide. The stale air is then breathed out the same way it came in. Mammal lungs have a different internal structure, but also work like a bellows.
As you might expect, it's not quite that simple. You see, both alligators and savanna monitors both have parts of their respiratory system which, like in birds, are one way. That's per the 2010 paper Unidirectional Airflow in the Lungs of Alligators by Firmer and Sanders, and the 2013 paper Unidirectional Pulmonary Airflow Patterns in Savanna Monitor Lizards by Schachner et al. Of course, Sarfati and Carter, our most esteemed authors, either are lying or didn't do their homework when they declare that reptiles simply have bellows-type respiration. Further, there is one major group of reptiles with avian-style respiration. That is, birds. This is sort of like saying foxes aren't canines because they have slit pupils and canines have round pupils. Well, okay, but that's never been diagnostic for canines, so pretending that a thing that makes foxes unique among canines makes them not canines is a bit silly. This is also the kind of thing creationists do to pretend that humans aren't apes. They say why humans are unique among apes, without ever attempting to show that humans lack the diagnostic traits of apes. Finally, I'd like to add that since this article was published on creation.com in 2015, there is indication that at least one species of iguana may also have unidirectional breathing, which is not terribly surprising as monitor lizards and iguanas are probably closely related in the clade Toxicophora, which would also include Gila monsters, the Mexican beaded lizard, mosasaurs, and snakes. Also interesting is that alligators are archosaurs, like birds.
However, birds have a complicated system of air sacs that makes use of even the hollow bones. This system keeps air flowing in one direction through special tubes, parabronchi, singular parabronchus, in the lung, and blood moves through the lung's blood vessels in the opposite direction for efficient oxygen uptake, an excellent engineering design.
And one that we see in other dinosaurs. For example, all saurischians have extensive pneumaticity and air sacs. Even sauropod skeletons were extensively pneumatic, especially along their vertebrae. In fact, between each pair of cervical ribs was an air sac. Further, we know that Majungasaurus, a Malagasy abelisaur, had air sacs directly homologous to a bird's, which puts bird respiration probably at the very latest at the base of Saurischia. But we also know that pterosaurs had pneumatic bones like theropods, including modern birds, and so they also likely had a similar pulmonary system, pushing this all the way back to before dinosaurs. Further, many terrestrial pseudoseuchian or crocodile archosaurs also had extensive pneumaticity in their skeletons. So this dependence on air sacs facilitating a unidirectional pulmonary tract might go as far back as Archosauria. So this is basically like asking how birds could evolve from dinosaurs given that birds have a spine but dinosaurs don't. The simple answer is that dinosaurs do in fact have spines, and have had them since long before dinosaurs diverged.
How would the bellows style of reptile lungs evolve gradually into avian lungs? The hypothetical intermediate stages could not conceivably function properly, meaning the poor animal would be unable to breathe. One of the first developmental stages would be a poor creature with a diaphragmatic hernia, hole in the diaphragm, and natural selection would work against this. Also, the air sacs require a fixed thigh bone for support. In birds, the thigh is inside the body, and what seems like its knee is equivalent to our ankle. However, dinosaurs had movable thighs, so it could not have supported an avian lung system.
Well, no creature would be left with a diaphragmatic hernia, because reptiles don't have diaphragms, and only the crocodilians seem to even have a fake diaphragm attached to their liver. There was a report that Cynosuropteryx had signs of a crocodilian-like hepatic piston pulmonary system, but that has since been shown to be wrong. See, Sarfati and Carter don't even know enough about reptiles to know that they don't have diaphragms. As for the fixed thigh bone, bird thighs are neither inside the body wall nor fixed. They are generally hidden by contour feathers, but if you've ever cooked a whole turkey or chicken, you'll know that the thighs aren't inside the body. Instead, they are connected by a lot of skin, but that skin remains flexible. In fact, here's some x-ray of a bird walking up an incline. Now granted, when walking on level grounds, birds rarely move their thighs, but the claim wasn't just that birds don't move their thighs, it's that they can't. So again, just based on this x-ray footage, no. Birds do not have immobile thighs, and so a fixed thigh can't be some kind of necessity for avian respiration, because birds, like all other theropods, move their thighs.
Recent research shows that some reptiles, including iguanas, monitor lizards, and alligators, have a form of unidirectional airflow. However, they don't need the avian system of air sacs and parabronchi. Instead, the airways are shaped and angled to generate jets that produce one-way airflow, an ingenious design that humans may never have imagined possible.
Oh, so you did know that reptiles don't just have bidirectional lungs. Funny that. Okay, so how about this? You have lungs with one-way airflow and blood vessels that already have one-way flow. Now you extend little pockets off of the lungs, which is all lobes of the lungs are anyway. They infiltrate the limbs. Now the limbs and general movement greatly increase airflow, reducing the need for the lungs themselves to expand. And since blood is only flowing one way, you're getting efficient oxygen transfer across a fairly rigid lung with air sacs. It's almost like this is pretty easy.
This has generated more problems than it solves. First, it means that the energy requirements for flight could not have provided selection pressure for one-way airflow, because it also occurs in heavy, non-flying creatures. Second, one-way airflow could not have been a selective force for driving the evolution of hernias, air sacs, parabronchi, and the fixed thigh, since it can exist without these features.
You say these are problems, I say they are features. Something that's a feature and not a problem for my channel are my channel members and patrons. I want to take a little time to thank my channel members and patrons, especially those pledging $20 or more. Bob Knob, Bent Hovend, Ian Chen, Chris Love, Sphincter of Doom, The Venerable Bede, Patrick Dennis, and Res Instance. YouTube is a very volatile platform, what with fraudulent copyright claims, demonetization, and the ever-decreasing share of ad revenue on the platform. It is very hard to rely on YouTube. My members and patrons help keep this channel going, and without them, the channel wouldn't exist. If you'd like to join my Patreon, the link is in the description, and if you'd like to become a channel member, that link is below the video. It's the join button here on YouTube. Either way, you'll get access to early videos, an exclusive Discord server, and if you pledge enough, 3D assets you can use in your own projects.
Archaeopteryx, at its largest, was only about the size of a raven, but has an outsized place in evolutionary claims. Its fossils were first discovered in Bavaria in 1861, with the interesting combination of clear feathers and wings, as well as teeth and a tail. As this was only 2 years after Darwin published Origin of Species, it was quickly hijacked as one of the intermediate forms he predicted, an intermediate between reptiles and birds. However, it did not have intermediate features. Rather, it had many fully avian features. Perching foot. This means that its wings would have needed to be sophisticated enough to produce the special wing turbulences, leading-edge vortices, like those of modern birds, so that it could land delicately on a branch.
Except no, it didn't have a perching foot. The apparently inverted digit 1 on the pes of the London specimen was a taphonomic artifact. That being said, Archaeopteryx probably did spend a lot of time in the trees, but it probably used both its hands and feet to clutch onto trunks or large branches.
Classical elliptical wings like modern woodland birds.
Yup, no argument there. Wing shape can evolve relatively rapidly, as it's basically the same thing in a mammal as varying leg length and hair length. Something we see vary considerably among animals even CMI would accept as genetically related.
Fully formed flying feathers, including asymmetric veins and ventral reinforcing furrows as in modern flying birds.
And no one that I know of is claiming that Archaeopteryx falls outside of Penaraptora, the clade in which such feathers appear. Not sure why this is mentioned, but hey.
A large wishbone for attachment of strong muscles responsible for the downstroke of the wings.
While it does have a larger than average wishbone, or more properly, furcula, compared to other theropods of its size, it's not nearly as derived as we see in even relatively primitive birds like groundfowl. It's basically the same shape as the furcula of a Tyrannosaurus rex. It's actually far more basal than you might expect given how outwardly bird-like Archaeopteryx would look.
The unique avian lung design with air sacs, fixed thigh, and one-directional airflow.
But as we've already covered, this will be expected even in a much less bird-like dinosaur.
And finally, Archaeopteryx, despite the fact that it could fly, and despite the fact that it has several non-bird-like reptilian features, like a long, bony tail, is out of place for the evolutionist. Too many other birds and bird-like fossils have been discovered that predate it.
What? I seriously don't know what to do with this sentence. Having basal non-bird traits is what we should expect to see in a transitional fossil. That's what makes it transitional in the first place. Archaeopteryx had a long bony tail with no picostyle, it had thecodont teeth, it had no keel on its sternum, it had unfused wing fingers, it had a dew claw like Hallux rather than an inverted one like a perching bird. It also had a hip that was more or less identical to Velociraptor, and not very much at all like those of modern birds. I mean, this is precisely what you'd expect to find if birds evolved from dinosaurs. You'd see animals with many more basal traits mixed in with some derived avian traits.
Cynosuropteryx was another small creature, only 1.07 meters, 3.5 feet long, yet classified as a theropod, the same group to which T. rex belongs. But with 64 vertebrae in its tail, it had the longest tail relative to body length of any theropod. Discovered in northeastern China in 1996, it was the first claimed feathered dinosaur. It also had remarkable preservation, enabling study of some of its organs. However, in two major ways, this creature must disappoint evolutionists. It lacked the unique avian lung. Instead, it had a crocodilian-like hepatic piston respiratory system, working on the normal reptilian bellows method. John Rubin, a respiratory physiology expert at Oregon State University in Corvallis, concluded that Cynosuropteryx's, quote, bellows-like lungs could not have evolved into the high-performance lungs of modern birds, end quote.
Carter and Sarfati rely on a quotation from John Rubin, a bandit, for this claim. Of course, the claim is based on Rubin's examination of undescribed specimens. The actual specimen of Cynosuropteryx wasn't even described and named until the following year. While it's not exactly wrong to write on photographs, standard paleontology practice is to wait until a specimen is described before commenting on it, and to not write on it based only on photographs unless absolutely necessary. Either way, the initial description, which Dumb and Dumber here could have referenced, would have basically agreed, but since Rubin's paper is from 1997, and the description is from 1998, perhaps the creationist version of Google Scholar has a cutoff of 17 years, and won't return results newer than that. Either way, in 2001, the claim that the observed stains represented a hepatic piston-type pulmonary system in the original fossil of Cynosuropteryx were largely refuted by Curie and Chen in Anatomy of Cynosuropteryx prima from Liaoning, northeastern China, in the Canadian Journal of Earth Science. And as far as I can tell, that Chen is the same Chen who was lead author on the original description, including the claim of a crocodilian-style hepatic piston. So not even the scientist who first actually reliably reported on this claim still buys into it. So here are the two creationist bird-brained buffoons repeating a claim that hasn't been current in the literature in 14 years by the time they wrote this dribble. And they were reporting on a claim that was really only taken seriously for fewer than 4 years.
Also, its feathers' filaments were most likely nothing to do with feathers. Rather, in the typical arched back position in which we find many dinosaurs' fossils due to perimortem submersion, the thick integument skin on the animal's back was buckled, which would be possible only if the filaments were part of a single structure, not separate feathers. Professor Thiergarten Lingam Soliar of the University of KwaZulu-Natal, South Africa, argued that the filaments were part of, quote, a clearly unified structure, i.e., an upright frill or crest overlying the neck, back, and tail of Cynosuropteryx, as opposed to individual protofeathers, end quote.
So, a few things. The first bit of this section only references another Creation.com article by Johnny Boy Sarfati himself. That article itself doesn't have a list of references, and the hyperlinks I checked themselves go back to Creation.com. Now, it's not that it isn't okay to write an article on a non-peer-reviewed venue about science, but when you need to reference something, your reference should always go back to the actual source. And since Sarfati is a chemist, not a paleontologist or ornithologist, he's not the kind of person who should be referencing himself on dinosaurs anyway. Second, the paper the rest of this relies on, by Lingam Soliar, is entirely built on the false premise that the only reason the scientists who discovered melanosomes on Cynosuropteryx had for declaring them to be melanosomes was that they were looking at compressed scanning electron microscope images that made it look like Cynosuropteryx had stripes from such structures. In fact, the paper Fossilized Melanosomes and the Color of Cretaceous Dinosaurs and Birds by Zhang et al., published in Nature February 25th of 2010, has detailed and high-definition pictures of individual melanosomes at the sub-micrometer scale, each one being around half a micrometer in diameter. Further, similar structures are observed in a fossil Confuciusornis with about the same, if not smaller, scale. It's hard to conclude that Lingam Soliar knows what he's talking about. At best, he's outdated in his information, but his objections simply hold no water. Now, I do want to note that in the original video, if you can call it that brought this article to my attention, the narrator rather comically said that perhaps these melanosomes were in the skin, and since Lingam Soliar said that these filaments were collagen from the skin, that dermal melanosomes were the source of these structures. The problem is that Zhang et al. Report these structures inside the filaments, and collagen filaments don't have such structures. So no, this just shows that my critic is even worse at biology than Sarfati, who himself simply uncritically accepted the work of banned hacks.
The dating, even by evolutionary methods, shows that their order is wrong. Archaeopteryx is allegedly 153 million years old, but their alleged feathered dinosaur ancestors, such as Cynosuropteryx, are dated to 125 million years old. This problem is accentuated by another extinct bird called Confuciusornis, which even had a toothless beak, but is dated to 135 million years old. Thus, by the evolutionists' own methods, Archaeopteryx and Confuciusornis are dated as being millions of years older than their alleged dinosaur ancestors. Evolutionary paleoornithologist Alan Fiducia, a well-known critic of the dino-to-bird dogma, often quips that you can't be older than your grandfather.
There simply is no grandfather paradox. Confuciusornis and Archaeopteryx are from the late Jurassic, which was a time of expansion for Coelurosaurs, the group of theropods that includes tyrannosauroids, raptors, oviraptors, ornithomimids, and yes, birds. By the time of the early Jurassic Yixian, we know that Coelurosauria was already diverse, and that Penaraptora was already a clade that was established, as were other coelurosaur clades, such as Tyrannosauroidea. By the end of the Cretaceous, several modern groups of birds had already evolved and would go on to survive the KPG extinction. But dinosaurs were already well established at this point, having taken over from Pseudotsuchians and Dicynodonts from the end of the Triassic onward. And even by the end of the Triassic, were already diversifying. In other words, the ancestors of birds would be found in the late Triassic and middle and early Jurassic. Dinosaurs existed for the whole of the Jurassic, so there is no problem here. That there are also organisms that are more or less bird-like is also no problem, as there is nothing about evolution that requires more basal forms to die off. One more recent example of this is the seahorse, an extremely dried fish. But if one looks through its family, Cygnathidae, from basal pipefish without brood pouches, all the way to vertically aligned prehensile tail-having male pregnancy seahorses. The same was true for birds. Some animals very close to birds, such as the Deinonychosauria or ornithomimids, were around at the same time as members of modern groups, such as Anserininae, that is waterfowl such as ducks, swans, and geese. Still though, using these relatively closely related outgroups can help us use techniques such as phylogenetic bracketing and evo-devo to learn more about the evolution of birds and what their actual ancestors were most likely like. But no one is proposing that these famously bird-like late Jurassic or Cretaceous animals are themselves the ancestors of birds. Rather, they are their cousins.
Dino-bird believers respond that sometimes a grandfather can outlive his grandson. But while correct, it's hard to understand that an advanced beaked bird, like Confuciusornis, could appear 10 million years before there is a trace of its feathered dino ancestors. Also, one of the major evidences of evolution is how the evolutionary order supposedly matches the fossil sequence. Therefore, the gross mismatch with the dino birds is a severe challenge to the evolutionary explanation.
What we're seeing here is almost certainly a taphonomic artifact. Places like the Yixian Formation or the Solnhofen limestone are exceptional fossil sites called Lagerstätten. The knowledge that such sites gives us about the ancient past is quite disproportionate to how much of the fossil record they account for. Generally speaking, most formations from which we extract dinosaur remains are not nearly as good in terms of preservation. For example, we have birds from the Lance Formation, but they do not preserve feathers. The Morrison Formation is famous for its extensive but relatively poor preservation of animals. The fact is that integument in most cases is just not going to preserve. Instead, to recover the likely skin or feather covering of animals, we have to use phylogenetic bracketing. It works a bit like this. you know naked mole rats do not have fur. But we know that their close relatives, beavers, rats, and capybaras, all do. So now we find a skeleton in the fossil record that looks a bit like a mole rat, but it looks more like a basal rodent. Do you assume fur? Well, probably, since that's the basal condition for rodents. That's the default. So if several organisms all have what seems to be a shared homologous trait, then the likely answer to the question of whether a new organism in the same clade as all of them share that trait, even though you can't check directly, is yes. So we have good reason to think that even dinosaurs as basal as Coelophysis probably had simple filament like protofeathers, since we find such structures in Ornithischian as well as theropod dinosaurs.
At the time of writing, a flurry of new fossils have been discovered, and new discoveries are continually being revealed. The situation is in flux, and not even the evolutionists have a clear story. It may be that dinosaurs had feathers, but obvious birds have also been discovered and dated to deep within the dinosaur era. Not too many years ago, evolutionists were teaching that birds evolved right before dinosaurs went extinct. Now they say they evolved millions of years earlier than once thought. If birds evolved from dinosaurs, when? They may have run out of time.
Yup, birds evolved from dinosaurs in the Jurassic, deep in the Mesozoic. So finding birds alongside non-bird dinosaurs should be expected. It's kind of like saying, hey, primates are around today, but evolutionists say they evolved from mammals, yet the earliest primates date deep within the era of mammals, the Cenozoic. Of course they do. That just means that their divergence time from other mammals was fairly early. And of course we see their fossils alongside the fossils of other mammals. If we didn't, that would be weird. And if for some crazy reason all non-primate mammals were to go extinct tomorrow, and then primates and whatever else was left went on to establish new recovered ecosystems, the fossil record for primates alongside other mammals would remain, and presumably future creationists would complain about the mammal-primate grandfather paradox. Well, that's it for this article. There was another one that was referenced in the response video. Depending on how this video goes, I may or may not cover it. Of course, a lot of this stuff is stuff I've already covered in various places, but how can I turn up a chance to dunk on the abysmal scholarship of Carter and Sarfati, the Tweedledee and Tweedledum of CMI's dinosaur research? Oh well, don't forget to like this video if you liked it, and dislike it if you didn't like it. Tell me what you think in the comments. I'm the Dapper Dinosaur.
If birds evolved from dinosaurs, when? They may have run out of time. This is such a stupid article. Who wrote this? It's not the worst, but my goodness, people need to hire editors. Just hire an editor. Just do it.